25. Identify the quantity measured with the balance. Oh my goodness. The question says, a balance is used to determine the blank of an object. Mass or weight? On a balance. Mass. What about volume? No. What about speed? No. Okay. Some answer choices are just going to be silly. Now we have the short answer questions. Look, there are 7 of them this time. And you get to do calculations and show work, which is one of the reasons we did our mole activity today, so you can practice showing work. All righty. 26, you're going to convert from one metric measurement to another, but you must use factor label. And that's what we were doing today. So, within the metric system, I know you guys are good with moving your decimal, but I want to see this written as a conversion factor. So, say we have 0.015 kilograms, and I want to know how many grams that is. But I want to see it using a conversion factor. Okay? So I'm going to be looking for some sort of fraction here that relates the 2 units we're talking about in the problem. I want to turn kilograms into grams. So do grams go on the top or the bottom? Top, because that's what we're turning into. Then the unit that we already have goes on the bottom. Now this thing is your conversion factor. How many grams in a kilogram, or how many kilograms in a gram? 1,000 what? 1,000 grams is the equivalent of 1 kilogram. And we wrote them this way so that our kilograms can cancel out. And you're still ending up moving your decimal or multiplying by 1,000. What do we get for an answer? Let's see it in proper sig figs. Really? 0.015 times 1,000? We can't do that in our head? 15 what? Grams. How many sig figs does that answer have? 2. Right? Because our initial measurement had 2. Our conversion factor doesn't affect sig figs because this is an accepted quantity. Alrighty. 27 is similar. It will be a volume conversion, and you must use the factor label method again. So on your paper, I want to see some sort of conversion factor. You don't necessarily have to draw the nice box around it, but I want to see some conversion factor. That's what I mean when I say factor label method in the test question. 28, you're going to calculate the volume, and you are given the density and the mass. How do we do that? Let's do aluminum, since we know its density is 2.70 grams per centimeter cubed. It's the density of aluminum. And we're going to find, what did I say, volume? Okay, so we have a mass of aluminum that's 5.00 grams. What do we do to find volume? V equals what? How can I set up these measurement units to end up with a volume measurement? Let's pretend we don't know those numbers. We have grams per centimeter cubed, and we have grams. How can I put those two things together so that I'm left with centimeters cubed as my final answer?
Or 50 grams to cancel out?
You have to get grams to cancel out. So if I started with these grams, what would I multiply by to get the grams to cancel? What would I do to this unit? Flip it, right? Centimeters cubed over grams, and that would cancel. I'd be left with grams. Okay? Now, let's attach the numbers to that. How many grams did we have? 5. We have 5.0 grams of aluminum. And then what happened here? Let me move that over. When I flipped this, which of these is 1 and which of these is 2.7?
1 gram. 1 centimeter cubed.
1 centimeter cubed, 2.7 grams. Okay? So I'm taking mass divided by density to get volume. If you can't remember, I showed you this way, because if you can't remember the equation, adjust your values so that the units cancel out, and you'll automatically be doing the right equation. Okay, so don't freak out about memorizing, well, density is this, and mass is that, and volume's this. If you know one of them, you can always just flip the units around to get the others. 29 is going to combine a couple things. You're going to be given volume and mass, and you'll be asked to find density of a substance. You're also going to be given the accepted value